Good day. For this particular lecture video, I'll be talking about colligative properties of solutions, most specifically on electrolyte solutions. The following would be the lesson objectives for this lecture. Number one is to define colligative properties of electrolyte solutions. Number two is to identify the Van Hoff factor of an electrolyte. And then number three would be to calculate colligative properties of electrolyte solutions. Now, colligative properties. Let's recall what colligative properties are. Colligative properties are properties of solutions, as the highlighted phrases denote, that depend ideally only on the number of solute. Take note that whenever we are talking about colligative properties of solutions, we are actually focused not on the nature, but rather on the quantity or the number of solute. So lagi po natin tandaan kapag ang usapin po ay patungkol sa colligative property, ang usapin ay tumutukoy sa bilang ng solute at hindi sa nature ng solute. So we're focused or we're mainly concerned with the number of solute and not on the nature of solute particles. Okay, so that's colligative properties. Now what about electrolyte? Now electrolyte is different from non-electrolyte. Okay, so electrolyte and non-electrolyte. So what's the difference? Electrolyte are ionically bonded substances. Okay, so ionically bonded substances like ionic compounds act like an electrolyte. Now, electrolytes dissociate into ions in a solution. Okay, so whenever electrolytes or ionic compounds are put or added into a solution or formed into a solution, they typically dissociate, or in other words, break down into ions. Whereas non-electrolyte are covalently bonded compounds, or in other words, covalent compounds in which no ions are present. So meaning to say, whenever covalent compounds or non-electrolyte materials are added or formed into ions, they do not dissociate to form ions when dissolved. Ibig sabihin lang po, ang mga electrolyte po o yung mga ionic compounds kapag sila po ay inihalo o idinagdag para gawing solution, nagdi-dissociate o nagdi-breakdown into ions. Habang ang non-electrolyte bilang mga covalent compound, wala itong ions. Kaya kung ito ay ihalo o gagawing solution, they do not dissociate or they do not break down to form ions. Okay, so remember, ions can conduct electricity. So that is why electrolyte or electrolyte compounds or electrolyte materials can conduct electricity, and then non-electrolyte compounds or non-electrolyte materials or substances cannot conduct because they do not form ions. Okay, so that's the main difference between your electrolyte and non-electrolyte. For this particular lecture, we are actually focused on electrolyte solutions. Okay. Recall that colligative properties are dependent on the total number of solute particles present. So muli po nating alalahanin na kapag usaping colligative property, tayo po ay nakafocus, tayo po ay tumutukoy kung gaano kadami ang solute particle. Ngayon, dahil pinag-uusapan natin ay colligative property ng electrolyte, mayroong bilang ang ions. To account for the total number of ions, we shall use the Van Hoff factor, represented by I. Ulitin ko po. Sa usaping colligative property, tayo ay tumutukoy o tayo ay nag-focus sa bilang o quantity ng solute particle. So solute particle, bilang ng solute particle, yan ang focus. E kaso, sa usaping colligative property ng electrolyte, muling alalahanin ng electrolyte kapag ginawang solution, nagiging ions. So paano natin mabibilang? How do we account for the number of ions plus number of solute? We account the number of ions formed from the dissociation of electrolyte solution through the Van Hoff factor. So, ibig sabihin po, kapag colligative property ng electrolyte, merong dagdag na Van Hoff factor. Okay? Para maibilang natin, para ma-account yung mga ions na mag-form kapag ang electrolyte ay nagdi-dissociate. Okay? Maliban na dito sa number of soup. So let's talk about Van Hoff factor. Van Hoff factor, or represented by I, accounts for the total number of ions. So the very purpose of Van Hoff factor is to count, or to, as the word suggests, account the number of ions present. So para mabilang natin kung gaano kadami yung ions na ma-form. The Van Hoff factor for electrolytes, sorry for the typographical error, depends on the total number of ions formed with the substances dissociates. Again, the Van Hoff factor for electrolytes depends on the total number of ions formed with the substances dissociates. However, the Van Hoff factor for non-electrolyte is always equal to 1, since there are no ions formed when it dissociates. Ano pong ibig sabihin nitong slide na ito? This one, the first concept, would like to tell us that if we want to compute or determine the Van Hoff factor of an electrolyte, we will look into the number of ions formed when the substances dissociate. Ibig sabihin po, malalaman po natin ang Van Hoff factor ng electrolyte solution sa pamamagitan ng pagbibilang kung gaano kadaming ions ang na-form from the dissociation. Okay? Now, how about the Van Hoff factor for non-electrolyte? Again, sorry about the typographical error. It lacks letter T. Kapag po gusto nating alamin ang Van Hoff factor ng non-electrolyte, lagi pong number 1. Okay? Automatic yan. Okay? For example, compute for the Van Hoff factor of this particular covalent compound. Ang covalent compound non-electrolyte. So, no-brainer. 1 agad ang Van Hoff factor. Automatic po yan. Uling tandaan, kapag pinapahanap ang Van Hoff factor ng non-electrolyte, laging number 1. Bakit number 1? Since there are no ions formed when it dissociates. Wala namang ions na napo-form yan. So, ang Van Hoff factor, laging 1 pag non-electrolyte. Pero kung babalikan yung electrolyte solutions, ito, nagdi-dissociate into ions. So, mabibilang natin. Okay? So, how is the Van Hoff factor computed? The Van Hoff factor has this particular equation. Van Hoff factor, that is I, is equal to the actual number of particles in solution after dissociation all over number of formula units initially dissolved in solution. Ano daw? Ganito lang po yan. Itong numerator, it pertains to the number of ions or particles that was formed, whereas the denominator pertains to the number of ionic compounds or formula units initially dissolved. Let me give an example. Okay, so practice exercise. How to determine the Van Hoff factors? So once again, this is your equation. So let us have here this one, sucrose. Okay, so let me use this one. Okay, this one. All right, so we need to determine the Van Hoff factor of the following. Okay, so I think I have it here, no, this one. Okay, so what about the Van Hoff factor? So the Van Hoff factor is letter I. So I. Okay, so susundan lang po natin the equation. Actual number of particles in solution all over number of formula units initially dissolved. Now we have here sucrose. Now kapag ang sucrose ay dinissolve at gagawing solution, ano kaya magiging Van Hoff factor? Now, tandaan natin. We have here sucrose. Sucrose. Sucrose is actually a covalent compound. Okay? Covalent compound ang sucrose. At tandaan natin, kapag non-electrolyte, covalent compound. At dahil covalent compound ang sucrose. Ito ay tinatawag nating non-electrolyte. Ulitin ko po. Non-electrolyte. Ang sucrose, isang uri ng covalent compound. At base sa definition, kapag covalent compound, non-electrolyte din. Ano ang Van't Hoff factor kapag non-electrolyte? Automatic number 1. Kasi ang mga sucrose o mga mga covalent compound or non-electrolyte kapag sila po ay dinisolve, equal pa rin po sa 1 ang Van't Hoff factor. Ayan. Sucrose dissolved. Sucrose is an example of a non-electrolyte covalent compound. Remember, ang Van't Hoff factor ng mga covalent or non-electrolyte compounds ay laging 1. Okay, so ang Van't Hoff factor for sucrose, since this is a non-electrolyte compound or covalent compound, should be 1. Okay, so we are just applying the rule for non-electrolyte. Okay, now what about NaCl? Now NaCl is actually an electrolyte. Okay, electrolyte. So ito electrolyte na ito dahil ang sodium chloride ay isang uri ng ionic compound. The ionic compound, this is made out of metal, non-metal, NaCl. Ito ay metal and then non-metal. Okay? So ionic. So dahil ito ay isang ionic compound, ibig sabihin ito ay electrolyte. So paano natin i-solve ang I? Okay? Now, when sodium chloride dissolved, it becomes 2 particles. It becomes sodium and chlorine. Ano daw? Ano yung sabihin nun? Paano naging nangyari yan? Explain po natin. Ang NaCl po, kapag dinisolve sa isang solvent or ginawa nating solution ang NaCl, magdi-dissociate. Pag sinabing dissociate, magbi-breakdown. Paano? NaCl, magbi-breakdown o maghihiwalay, magdi-dissociate into Na plus chlorine negative. Saan ba gawa ang NaCl? Gawa sa sodium at chlorine. Sodium positive, chlorine negative, di ba? Kapag kinilis cross method niyan, kapag gumagawa tayo ng ionic compound formula, you have NaCl. So gawa po sa Na plus at chlorine negative ang NaCl. So ilan to? Meron kang total of 2 particles. Okay? Ito ay gawa sa NaCl, dalawa. Okay? So ngayon, gamitin natin ngayon yung formula. Actual number of particles in solution after dissociation. Ang numerator natin, ilan daw ang particles after dissociation? So after dissociation, ilan ang NaCl or ilan ang particles na na-form? Dalawa ito. After the dissociation of NaCl, we have 2 particles. How about the denominator? Number of formula units initially dissolved. Ilan ang dinisolve? Ibig sabihin, ilan yung formula units na ating dinisolve? Oh, look at the given. NaCl. Ilan yan? Isa lang. Isa lang ang dinisolve nating NaCl. So 1. I is equal to 2 over 1 or 2. The Van't Hoff factor for your NaCl is 2. Ganun lang. Ganun siya kadali. Sige, let me give another example. So I have here FeCl3. FeCl3. Now, iron 3 chloride, this is electrolyte. So electrolyte na naman po to dahil ito ay isang ionic compound. So how is this formed? So when iron 3 chloride is undergone or undergoing dissociation, it will form Fe3 plus and chlorine negative. Okay, Fe3 plus and chlorine negative. Now, how many particle is this? We have here 4 particles. So how is this 4 particles? So this is 4 particles because we have here 3 chlorine, Okay, so tatlong chlorine ang meron tayo dito. Ito ay gawa sa Fe3+ at chlorine negative. So tatlo. Okay, so tatlong chlorine. Okay, so FeCl3. Ayun na, pag nag-dissociate tayo, okay, when it dissociate, meron kang isa, ayan, isang ion, and then meron kang, sorry about that, meron ka naman ditong tatlong chlorine. Okay? Yeah, so we have here 4 particles. So how is this computed? So I is equal to how many particles are, or how many particles after dissociation? Meron tayong 4. And then how many is the initial formula unit? We have 1. So I is equal to 4. So the Van Hoff factor for FeCl3 is 4. Okay? So ganun lang po ang pag-compute ng Van Hoff factor. Okay, so let me give more example. Sige, let me give more example. So practice exercise, glucose. So we have here glucose. Now glucose is, once again, this is non-electrolyte. Ang glucose po ay isang uri ng covalent compound. So dahil covalent compound ang glucose, covalent compound, automatically non-electrolyte, so ang Van Hoff factor ay 1. Okay, 1. How about NaCl? Okay, so NaCl naman ay, actually, ang clue lang dito ay shortcut. Sige, tuturo po natin siya. Ang shortcut lang dito ay, kahit hindi po natin gamitin actually itong formula, itong equation, paano magiging clue? NaCl. Bilangin nyo, ilan ang atoms? You have here 1 atom of sodium, and then you have here 1 atom of chlorine. And then we just need to, bilangin lang po kung gaano kadaming atom ng element. So total we have 2. So the Van Hoff factor would be 2. Ganun lang. So kahit hindi niya po ito gamitin itong equation, meron naman po tayong shortcut na ito, bibilangin niyo lang kung gaano kadami yung atom. So you have here 1 atom of sodium and then 1 atom of chlorine. So 1 plus 1, Van Hoff factor is 2. So kahit hindi niyo po ito gamitin, pwedeng shortcut yan. Ang shortcut ay sa pamamagitan ng pagbibilang kung gaano kadaming atoms ang meron sa kada substance. So we have 2 substances or 2 components, dalawang component, sodium at chlorine. Tig-isa. So number 2. Pero kung i-check po natin yan sa main equation, okay, so we actually have here number of particles formed after dissociation, dalawa. Because when sodium chloride dissociates, you have here sodium and chlorine. So tig-isa pa rin naman. So 2 ang numerator. How about denominator according to the formula? Number of formula units initially dissolved, meron kang isang sodium chloride, so number 1. So I is equal to 2. Parehas pa rin. And then last one, calcium Cl2 or calcium chloride. So shortcut, meron kang isang calcium. Meron kang dalawang chlorine. So 1 plus 2, 3. Okay, so you have here the Van Hoff factor is 3. Okay? Ayan. So pwede nyo po gamitin itong shortcut. Okay? Na-i-add lang po natin yung mga number of atoms or number of substances within the formula. Or you may simply use the Van Hoff factor formula. So check natin, what if gamitin natin yung Van Hoff factor formula? CaCl2. You have here calcium 2+. Meron kang isang calcium 2+. And then, meron kang dalawang chlorine negative. Okay, so pag nag-dissociate po to, meron tayong isang calcium 2+, isang calcium 2+, at kapag nag-dissociate ng calcium chloride, meron tayong dalawang chlorine negative. So ang total ay 3. Okay, so we have here 3 particles formed. So according to the formula of Van Hoff factor, 3 is the number of particles after the dissociation. And then the denominator would be the number of formula units initially. So initially we have here 1. Isa lang po yan, isang calcium chloride. So 3/1, you have 3. Okay? So that is how we solve for the Van Hoff factor of our electrolyte solutions. Madali lang po. Pwedeng gamitin itong formula o pwede rin po gamitin yung simpleng pag-a-add po ng ating mga components. Pag-a-add ng components. Okay? Ayan. So hopefully this is clear. Now at this point, since we're talking about colligative properties of electrolyte solution, okay, so there are also such colligative properties discussed. So same goes with non-electrolyte and electrolyte. Kapag usaping electrolyte, pare-pares lang naman po ang colligative property. Vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure pa rin naman po. So ibig sabihin, you have 4 equations for non-electrolyte, and then you have another set of 4 equations for electrolyte. Huh? Bago na naman? Yes po. Pero anong pinagkaiba? Okay, so let me explain. They are actually the same. Okay? The same, but there are just some minor tweaking. For the colligative properties of non-electrolyte, naalala po natin, meron tayong 4 na pares ng equation, or we have here 4 different equations. Now for colligative properties of electrolyte, meron na naman pong bago. Ano lang ang pinagkaiba? Tignan. Ang vapor pressure lowering is equal to the Van Hoff factor times mole fraction of a solute times vapor pressure of a solvent. Boiling point elevation is equal to I times K sub Bm. Freezing point depression is equal to I KFM. Osmotic pressure is equal to I MRT. Pansinin, nadagdagan lang ng Van Hoff factor. Pero kung isipin nyo, ito pa rin naman yung equation na natutunan natin sa colligative property of non-electrolyte. This is still, or these are the following equations for non-electrolyte. The only difference for electrolyte solutions is you have the Van Hoff factor. Because remember, the purpose of having the Van Hoff factor is to account the ions formed from the electrolyte. Yun lang po. Yun lang ang pinagkaiba. Parehas pa rin ng forma ng equation tulad ng non-electrolyte. Ang pinagkaiba lamang po kapag electrolyte solution, meron lang factor na letter I. Meron lang Van Hoff factor. Okay? To account for the number of ions formed from the electrolyte solutions. Okay? Ayan. So let me give an example on how we apply them. Okay, so before that, these are your common Van Hoff factor. Ayan, ito yung mga common Van Hoff factor. So let me discuss this briefly. Ito yan. Pansinin, ito po. Okay? So kindly focus on the third column. This is the calculated Van Hoff factor, while this is the measured Van Hoff factor. For our discussion, or for the context of our discussion, or for the sake of our discussion, we need to focus on the Van Hoff factor calculated. We are not concerned with the measured. So do not focus or do not be concerned with the Van Hoff factor measured. But for the sake of discussion and computation purposes, we are focusing here on the Van Hoff factor calculated. Okay, so look at sucrose. Okay, sucrose. Sucrose is non-electrolyte. Ang Van Hoff factor ay 1. Kapag non-electrolyte, ang Van Hoff factor 1. Okay. HCl. HCl in this context is electrolyte. So, paano nalaman? Ang Van Hoff factor ng HCl ay 2. Paano naging 2? HCl. Okay, balikan natin ito. HCl. Shortcut, mayroong 1 hydrogen, 1 chlorine. I is equal to 2. Shortcut. Or kung gusto nyo gamitin yung formula, 2 particles after dissociation, and then you have 1 HCl, 2/1. Okay? Okay, NaCl. NaCl is electrolyte. Electrolyte. Van Hoff factor, 2. Paano naging 2? Ano lang din po, NaCl. 1 sodium, 1 chlorine, I is equal to 2, or using the equation, 2/1. 2. Okay? Ganun lang po yan kadali. Para alamin ang Van Hoff factor. Okay, so papaano naman ang next? Ito, MgSO4. Magnesium sulfate ay electrolyte. Ang Van Hoff factor ay 2. Okay, wait lang. Bakit 2 lang ang Van Hoff factor ng MgSO4? Madami ako nakikita. Okay, explain ko po. MgSO4. Magnesium. Isa. SO4. Ito ay sulfate. Ilan? Isa. Okay, ito po ay monoatomic ion. Ang SO4 po ay polyatomic ion. Diba sa periodic table, SO4 sulfate. So ang total lang yan ay 2. And then using the equation, 2 particles dissociated and the total number of initial would be 1. So 2/1, 2. And then MgCl, this is electrolyte. The Van Hoff factor is 3. Why? So MgCl2, we have 1 magnesium, and then we have 2 chlorine. So for the Van Hoff factor is 3. And then last one is FeCl3, electrolyte. FeCl3, we have 1 ion and then 3 chlorine. Van Hoff factor is 4. Or using the equation for the Van Hoff factor, the dissociated materials are 3, or rather 4, all over 1, because the initial is FeCl3 being 1 formula unit, we have Van Hoff factor 4. Okay, so ganun lang po ang pag-compute ng ating mga Van Hoff factor. Madali lang. Okay. Now let me give this first example. Okay, so let's have the first example on how to apply colligative property of electrolyte solution. What is the boiling point of the following solution? 21.2 grams sodium chloride with a molar mass 58.44 gram per mole in 135 gram of water. Okay, so ang ating given is 21.2 grams of NaCl. This is your solute. And then you have your 125 grams of water. This is your solvent. Okay, and then the requirement is boiling point. Equation, since boiling point ang nawawala, ito po ang gagamitin natin. Boiling point elevation. Change in PB is equal to I kBm. Okay, so boiling point elevation I kBm. So why is it we have a Van Hoff factor? Kaya po may Van Hoff factor dito dahil tignan ang solute. NaCl. May Van Hoff factor. So ibig sabihin, ganito po yan. Gagamitin lamang ang equation ng pang-electrolyte or colligative properties of electrolyte solution sa tuwing ang solute ay electrolyte. Okay, so ulitin ko po. We will only use the equations for electrolyte colligative properties if the solute are electrolyte. Okay, and then likewise, when the solute are non-electrolyte, you will use the non-electrolyte colligative property equations. So dahil ang solute natin sa problem na ito ay NaCl electrolyte, I will have a Van Hoff factor. Okay, so let's check if the following given are provided. So the Van Hoff factor. So compute for the Van Hoff factor, since we need Van Hoff factor for the equation. So the Van Hoff factor for NaCl is, this is 1, and then NaCl is, or chlorine is 1, so we have a total of 2. Van Hoff factor is 2. Next is K sub B. This is constant. Our solvent is water. So therefore, our K sub B is 0.52. Ayan, need natin ng K sub B. So ang solvent natin ay water. Ito, H2O solvent water. So 0.52. 0.52 degrees Celsius per molal. So meron na tayong meron na tayong K sub B. So ang kulang na lang natin ay molality. Now the molality will come from here, solute over solvent. So we need to have molality. So that's mole of solute all over kilogram of solvent. Okay, so I need to compute for molality from scratch. Okay, so I need to convert. So my solute is grams. So yung kailangan natin ay mole value. So I need to convert 21.2 grams of NaCl molar mass. The molar mass of NaCl is provided 58.44. 1 mole all over 58.44 grams. Grams will be cancelled. Let's use the calculator here. 21.2 times 1 all over 58.44 up until 3 sig fig, 0.363. 0.363. 0.363 moles. So now I have the numerator, 0.363 moles. And then for the denominator for molality, we need kilogram of solvent. Ang binigay ay gram of water. So I need to compute or derive 135 grams of water multiplied by 1 kilogram all over 1,000 grams. Okay, so grams will be cancelled. This will be 135 times 1 over 1,000. We have 0.35. 0.135. So that will be the denominator in this end. Okay, so now input this on the calculator. 0.363 all over 0.135. We have 2.69 molal. So now we already have here our given. We have here our I, Van Hoff factor, K sub B, and then molality. So input now this on the main equation. So I is 2. K sub B is 0.52 degrees Celsius per molal. And then our molality, 2.69. Okay, so molality is cancelled. What remains is the unit degree Celsius, which is appropriate for boiling point elevation. So 2 times 0.52 times 2.69, we have 2.80. 2.80, 3 significant PQ. So change in T sub P. And then once again, this is not yet the final answer because this is just the boiling point elevation. What we need is boiling point. So that means we need to solve further by having a boiling point is equal to normal boiling point of solvent plus boiling point elevation. Okay, so the normal boiling point of the solvent. So according to the table, the normal boiling point of water, in this case, our solvent is water, 100 degrees Celsius. So that means 100 degrees Celsius plus 2.80 degrees Celsius. So final answer, 102.80 degrees Celsius is the boiling point. Okay, so that is how we answer the boiling point for a colligative property. So para lang din po siyang colligative property of non-electrolyte solution. Ang pinagkaiba lang po ay mayroon tayong Van Hoff factor. Okay. Next example, sample problem number 2. What is the freezing point of a solution when 66.5 grams of water, so the Kf of water, the molar freezing constant is provided, 1.86 degrees Celsius per molal, is mixed with 14.75 grams of electrolyte sodium nitrate. With a molar mass 85.0 gram per mole, the normal freezing point of water is 0 degrees Celsius. So let's write the given. So given are 66.5 grams water, solvent, and then 14.75 grams of solute, NaNO3, sodium nitrate. And then we have here Kf of water, 1.86. And then normal freezing point of water, 0 degrees Celsius. The requirement is freezing point. So therefore, our equation would be freezing point depression is equal to I KFM. O ngayon, bakit na naman may letter I? Kaya po may letter I, may Van 't Hoff factor dahil ito po ay electrolyte. Ayan. Ayan no, binanggit na ng problem na ang solute natin ay electrolyte. Muli pong alalahanin na equation na gagamitin ay pang electrolyte or may Van 't Hoff factor kung ang solute ay isang uri ng electrolyte. So ibig sabihin po, you need to check if the solute involved are non-electrolyte or electrolyte. So kung non-electrolyte, dapat walang Van 't Hoff factor kang gagamitin. Okay? Or automatically, kapag gagamit ka naman ng non-electrolyte, tapos gagamit ka ng Van 't Hoff factor, automatically number 1. Okay? So remember, kapag non-electrolyte, equal to 1 ang Van 't Hoff factor. But if ever that the electrolyte solution is present, like NaNO3, okay, so the Van 't Hoff factor for NaNO3, sodium nitrate, we have here 1 sodium, and then NO3. This is a polyatomic ion, NO3, isa lang yan. So you have 2. So the Van 't Hoff factor is 2. So using the formula as well. Numerator is particles dissociated. You have 2 particles dissociated. So this will be 1 sodium and then 1 NO3. So 1 plus 1, dalawa. And then the initial formula unit, that would be 1. So 2 over 1, you have 2. So the Van 't Hoff factor would be 2. So check if the following factors are given. We already have here the Van 't Hoff factor. And then we already have here the Kf. Okay, ito na po. May Kf at Van 't Hoff factor. Ang nawawala na lang po ay letter M. Kulang na naman po tayo ng molality. So molality is moles of solute all over kilogram of solvent. So we have your solute solvent, but in this case, our solute and solvent are still in grams. So we need to convert them into appropriate units. So for the solute, 14.75 grams multiplied by the molar mass of sodium nitrate, 85.0 provided na po. 85.0 grams. Grams will be cancelled. You have mole unit. Okay, so this one, calculator. 14.75 times 1 all over 85.0. 3 significant figure, 0.174. 0.174. Okay, so 0.174 moles for the numerator. For the denominator, what we need is kilogram. But what we have here is 66.5. 66.5 grams of water, so convert it into kilogram. Okay, so from the calculator, you have here 0.0665 kilogram. Okay, so input now this on the calculator. All over 0.0665. So up until 3 significant figure, 2.62 molal. So now, All the factors are provided. We may now proceed by typing now or writing the final solution. So change in the freezing point depression, I is 2, Kf is 1.86 degrees Celsius per molal, multiplied to 2.62 molal. Okay, so now cancel molal. What remains is degrees Celsius, appropriate unit. 2 times 1.86 times 2.62. We have 9.75. 9.75 degrees Celsius. Now, however, this is not yet the final answer because this is just the freezing point depression. Okay, so we just multiply the freezing point depression factor. So 2 times 1.86 times 2.62 molality, we have 9.75. So what we need to do is compute for the freezing point. So this is just the freezing point depression. So that is why freezing point is equal to normal freezing point of water minus freezing point depression. So the normal freezing point of water is provided 0 degrees Celsius. 0 degrees Celsius minus 9.75, we have negative 9.75 degrees Celsius for the freezing point. This is the final answer. Okay, so that is how we solve for the freezing point of an electrolyte solution involving the Van Hoff factor. Okay, last one, last example. Sample practice problem number 3. A solution that is isotonic with blood cells was prepared by dissolving 0.860 grams of sodium chloride once again. So sodium chloride is electrolyte. So notice or be aware that this will be another form of electrolyte or colligative property for electrolyte equation. In 99.5 milliliter solution, calculate the osmotic pressure of this saline sodium chloride solution at 37 degrees Celsius. Given 0.860 grams of NaCl, this is your solute, and then 99.5 milliliter solution. So this is already solution. And then temperature, 37 degrees Celsius. And then our requirement is osmotic pressure. So equation. Now again, this is electrolyte. This is an electrolyte solution. Paano nalaman na electrolyte? May NaCl. NaCl ang ating solute. So automatically, ang magiging formula natin ay osmotic pressure is equal to I mRT. So since this is osmotic pressure, mayroong R, 0.0821 liter atmosphere all over mole Kelvin. Okay, so we have already the R constant. How about the Van Hoff factor? So Van Hoff factor of NaCl, shortcut, we have one sodium and then one chlorine. So I would be 2. Okay. So how about the temperature? Temperature should be in Kelvin. So 37 degrees Celsius should be converted into Kelvin by adding 273. So 37 plus 273. Okay, so just to check. 37 plus 273. So we have here 310. 310 Kelvin. Okay. So it's very easy. 37 plus 273. 37 plus 273, 310. Okay. So what lacks now, according to our factor, is molality or molarity. Okay, so look at this one. This is letter M, capital M, so molarity. So it looks like we do not have any molarity provided, so we need to compute for molarity from scratch. That is moles of solute all over liters of solution. So we already have your solute and solution. The only problem is that they do not have appropriate units, so we need to convert them. So for the solute, 0.860 0.860 grams of NaCl multiplied by the molar mass. The molar mass of NaCl is provided by the problem, 58.44. 1 mole all over 58.44 grams. Grams will be cancelled. We now have unit mole. Input this on the calculator. 0.860 times 1 all over 58.44. We'll be getting up until 3 sig pig, 0.0147. 0.0147. 147. Okay. And then for the denominator, liters of solution. However, what we have here is milliliter. 99.5. Okay. 99.5 milliliter. Convert it into liter. 1 liter all over 1,000 milliliter. Cancel. What we have now is unit liter. 99.5 times 1 all over 1,000. We have 0.0995. 0.0995. 0.0995 liters. So mole per liter. We may now type this on the calculator as well to get the molarity. 0.0147 divided by 0.0995. We have 0.148 molarity. Okay. So now we have complete factors. We have here Van 't Hoff factor, we have molarity, we have gas constant, and then we have absolute temperature. So all factors for the equation are provided. So we just need to, input that. Input them on the equation or to solve the to solve for the osmotic pressure. So I would be 2 times molarity 0.148. So the unit for molarity is mole per liter. So we can rewrite that like as such. So this is 4 mole per liter. It's just the same. Gas constant 0.0821 liter atmosphere all over mole Kelvin times temperature 310 Kelvin. Okay, so show the cancellation of units. Liter, mole, Kelvin. What remains is the unit atmosphere, which is very appropriate for osmotic pressure. Okay, so that's osmotic pressure. Okay, so type this now on the calculator. 2 times 0.148 times 0. Okay, let me repeat. 2 times 0.148 times 0.0821 times 310. So 3 significant figure, 7.53 is the osmotic pressure of this particular colligative solution or electrolyte solution. Okay. So once again, this is just a simple colligative property equation. The only difference is that since this is electrolyte, mayroong involvement ng Van 't Hoff factor. So para lang itong pag-resolve ng simpleng osmotic pressure, yung parang sa non-electrolyte. Ang pinagkaiba lang ay, since ito ay electrolyte, meron kang Van 't Hoff factor na manggagaling dito sa solute. Okay? So hopefully that's clear. Okay? Right, so once again, these are the following lesson objectives. So number 1, to define colligative properties of electrolyte solutions. Number 2 is to identify the Van 't Hoff factor of an electrolyte. So hopefully we have done that. And number 3 is to calculate some colligative properties of electrolyte solutions using colligative property electrolyte solution equations. Okay. All right. I hope you learned a thing or two about colligative properties of solutions, particularly on electrolyte. I hope you learned a thing or two about how to compute for the Van 't Hoff factor, as well as problem solving or calculation for the said colligative properties. Okay. Thank you, and I hope you learn a thing or two about this lecture. Have a great day.